examples, and then after we will take our next practical. So let us start in that way. What we discussed in previous discussion of Aloha, that Aloha is very basic protocol. As soon as I am ready with my frame, I'm going to transmit it. Okay. So what then I will listen the channel, and if a collision happens, then I will wait for the random amount of time, and then I will resend. Okay. So and if I'm considering that G, if I'm considering that if my medium is shared among multiple users, then if I'm considering that N is total number of frames that are generated, newly generated new data that is to be transmitted, frames per frame time. What is frame time? That is the amount of time, that amount of time that is taken to transmit a frame, right? So that N frames are generated per unit frame time, right? And then if I need one more entity, that is G is the channel load. What is the meaning of channel load? That is the amount of frames that is existing in the channel that will be actually sent in the channel. So G will be, of course, if new frames are generated that are transmitted in the channel, so that will be, so G will be either equal to N if I don't have any retransmissions. But whenever collision happens, I have to retransmit the frame along with the new generated frames. So G generally is greater than or equal to N. When the load is low at that time, G will be almost near to N, but load is high, then retransmissions will be more because collisions will be more, and hence G will be greater than N. That is what we discussed in the previous lecture, right? Then also we discussed that if I want to reduce the collisions, then what I need is that whenever I'm transmitting, then no one should transmit. So in my frame time, definitely no one should transmit. But when I start transmitting, also no one already is transmitting, right? So when, in which duration no one should start transmission? Of course, whenever I am transmitting, at that time no one should start. That is my frame time. Plus also before my frame time, no one also should have also already they are should not be transmitting even in previous to my time slot. No one should have started transmission. They can start transmission here so that they can complete here, but not below. After that, not after that, no one anyone can start. Okay. So that is what we have already discussed. So that is vulnerable time. What is vulnerable time? The time in which if the frame is transmitted, if more than one frame is transmitted, they are subject to collision, they will collide. Okay. So that is vulnerable time. For my frame is it is 2 frame time. So that is also we have already discussed. Okay. Also, we discussed that Poisson's distribution we are going to follow. What is the meaning of Poisson's distribution? That how many frames will be generated? What the probability that k frames are generated will be given by the Poisson's distribution. This is the distribution that will be followed. In general, this will indicate the mean time, which mean number of frames that are generated. So just lambda. So probability of generating lambda frame is the highest one, and if you will take area under the curve, and then you will get the lambda is going to be your mean. In short, that lambda is what we can say that on an average, lambda frames per frame time are generated. Okay, so are in the network, right? So this is what we have already discussed, that Poisson's distribution it is going to follow. Okay, so what if I'm taking k, what is the meaning of that? What is the probability that k frames are generated per frame time? Okay, so if I'm taking k somewhere here, so if this is k, then this will give me pk. What is pk here? Pk is probability that k, this value k, k frames are generated per frame time. Okay, now I want to find out throughput. What is throughput? That probability that probability of successful reaching, probability that what we can say, probability that my frame will reach successfully without any collision. That is what is known as that throughput. Okay, so now what is the value of throughput here? How you can calculate the throughput? So what, see, first of all, I want to find out throughput. Throughput is what that the number of frames or the amount of data that will reach destination without collision. Is it clear? That is throughput. With successfully the amount of data that will reach the destination, that is throughput. Are you clear with the definition of throughput? Are you comfortable with the definition of throughput? What is throughput? That amount of data that will reach successfully at the destination. Is it clear? Okay. Okay. So now so now throughput S is what that the amount of data that will reach successfully. Okay, so now what I need to find, so what I need to do, suppose my data generated is G. Of course, what is the load generated? Load generated is G frames per second, and uh, probability that it will not follow the, it will reach successfully into P success. What is the meaning of this? That this much amount of data that is generated, and into probability that generated data will reach successfully. So that is going to give me the throughput. This will give me what? This is generated load, and probability that generated load will reach successfully. So can I say this is going to give me the throughput? This equation is going to give me the throughput. Now what I need to, G I already have, right? G I know what is the entity. Now I need to identify that what is the probability that generated frame will reach successfully. Okay, so you need to find out, can you tell me when my generated frame can reach successfully? In which scenario that generated frame can reach successfully? When I generate a frame, what is the probability that it will reach successfully? What is the condition for reaching this successfully? When generated frame can reach successfully? No collision. Yes, no collision. But in which duration there should not be? So no collision. When there will be no collision? What will be satisfied so that no collision will happen? What will be satisfied? What will happen so that no collision is ensured? If I have started transmission here, no, not G is equal to N. See, no collision will happen. That's why G will be equal to N. G will be equal to N. That's why no collision will not happen. Are you getting the point? Suppose collision is not happening, that's a retransmission will not be that. That's a channel load will be equal to the new generated packets. Okay, so no, that is not my question. Logically think. Um, Suppose I am generating the frame, right? So what will guarantee no collision? Suppose I have frame to transmit. What will guarantee what will guarantee there will not be any collision? Suppose I am speaking right now. What guarantees that it will not collide? Only one sender. True. Only one sender. That already I have frame. Then there should be any sender. Is there any? Should I have any other sender? If I am the sender, right? I have the frame, and I want to ensure that my data should reach successfully, right? So does anyone have data other than me, or other than asking like that, should we have any frame in the channel? Any other frame than me? No, there should not be any other frame other than me. That is the point. That means no one should generate. No, there should not be any frame in the given time. What is that given time? In how much time there should not be any frame so that collision will not happen? For how much duration there should not be any frame so that collision, there is no collision, that we can ensure that there will not be any collision? Okay, if suppose I have data to transmit, if someone will start here, some frame is there at this moment, then can I ensure the collision will not happen? So when can I say, before my time there should not be any frame, and during my time there should not be any frame? Yes, in vulnerable time, if there is no frame, that means it is ensured that my generated frame will reach successfully. After that, if someone generates, I will not mind at all. My frame will reach successfully. Are you getting the point? After this, if someone generates, it is not going to create any trouble with my frame. But before that, if someone generates, I'm going to collide with them, or during my transmission, if someone generates, then it is going to create the trouble. So what should happen? There should not be any frame generated in how much time? If I have frame to transmit, which I have, then there should not be any frame generated. There should not be any frame transmitted in the channel, not generated, not even transmitted. There should not be any retransmission attempt even, right? So there should not be any frame in how much duration? In vulnerable time. What is vulnerable time? How much is the vulnerable time? How much is the vulnerable time in pure Aloha? This is one frame time. This is another frame time. So what is vulnerable time? Are you getting, or should I repeat anything here? Yes, it is going to be 2 frame time. See, all of you have to answer me quickly. Otherwise, what will happen if we have a limited time? I'm not going to consider the examples. And examples will be, of course, you have to do it by yourself. I'm going to cover all the concepts, but examples I'm not going to cover, which is highly useful in the gate, right? So if you understand, answer quickly so that we can move forward, so that I will have a time to explain the examples. Otherwise, I'm going to cover all the syllabus topics, but not the examples, tricky examples, which will be helpful to you in the gate, right? So in case in case you understand, answer me quickly so that I can save the time. That's it. If not, answer me quickly so that I can explain again. But do not waste the time here. Okay, fine. So fine. So this will be 2 frame time. It will be 2 frame time. So in 2 frame time, there should be there should not be any frame. No frame should be there. That is what my requirement, so that my generated frame will be successful. So I need to find out what is the probability that no frame is generated in 2 frame time. Okay, fine. Now what I have, what I know a Poisson's distribution. What is Poisson's distribution say? What is the probability? I can know that what is the probability. I have equation of probability of generating k frames in 1 frame time. This equation we are not going to prove. This is just Poisson's distribution, right? What it says, the probability that k frames are generated in 1 frame time is given by this. We are not going to prove this. We are going to, again, no need to prove. This is just Poisson's distribution. Okay, like we are having equation for the Gaussian's distribution. Okay, so what is the probability that k frames are generated? The probability that k frames are generated in 1 frame time. Okay, what is the probability that the k frames are generated in 1 frame? What is my question? So what is G here? What was G? Do you remember what was G? What was G? Do you remember what was G? Total number of frame transmitted in 1 frame time. Absolutely, total number of sent frame, yes, Prince, but in how much time? In 1 frame time. And suppose I am using so total number of, not total number of, but average number of frames transmitted, average, and average number of total frame transmitted. I hope you are getting. That is average value of total number of frame transmitted. Total indicates here new plus retransmissions. Okay, but in 1 frame time. And what I was getting here, I was getting probability of transmitting k frames in 1 frame time. Now what I want to find out, no frames in 2 frame time. So what is the value of k? So let us don't think about 2 frame time, let us think about no frames. I want to find out what is the probability that no frame is generated in 1 frame time. No frame means what is the value of k? When I said I want to find out how many no frames are generated in 1 frame time, this gives me, say, k frames are generated in 1 frame time, but I want to find out No frames means how many frames? 0. So k value is 0, right? So if I substitute k value 0, what I'm going to get is that probability of 0 frame generated, no frame generated in 1 frame time. But I'm not interested in 1 frame time. I'm interested in 2 frame time. So I want to modify this equation for 2 frame time. So in 1 frame time, if g is the average number of frame generated, so in 2 frame time, what will be the average number of frame generated? In 1 frame time, average number of frame generators are g. So in 2 frame time, what is the average number of frame generated? 2g. Yes, it is going to be 2g. So this equation should be replaced with 2g. Then this equation is going to be, wherever g is there, I'm going to replace with 2g. Then this will give me the probability of generation of k frames in 2 frame time. Right? And then I want to find out k is equal to 0. That is probability of generation of 0 frames in 2 frame time. So can you tell me substituting k0 will lead to what value? It will be 2g raised to k. Like it will not be like um, right. It will be 2g raised to k. It will not be 2 into g raised to k. Right. So what it will be? 2g raised to k. K will be 0. So what will happen to this? What will happen to this? It will become 1. What will happen to this? Can you understand? Are you getting the point? Are you clear with that? What I need to find out? No frame generated in 2 frame time. So that means k value 0 and equation will be 2g raised to k e raised to, I mean 2g raised to k, like 2 raised to k into g raised to k kind of thing. No. What will be k factorial if k it is 0? K is 0 then? What is k factorial if k is 0? No. 0 factorial is 1. 0 factorial is 1. So this is going to be 1. What will happen to this term? What will happen to this term? It is also 1. So what will happen to this term? It will be as it is. So can you tell me what is probability of success? What is the probability of success? That is probability of no frame in 2 frame time. Be quicker, you are so late, too late. What is probability of success? Yes, e raised to minus 2g, right? Okay. And e raised to minus 2g, that will be substituted here. So what will be throughput? What will be throughput if I am substituting piece? Yes, it will be g into e raised to minus 2g. Yes, it will be g into e raised to minus 2g. Okay. Okay. And when do you think that throughput will be highest? What is the meaning of that? What should be the for which value of g, which is this is equation? What do you think for which value of g that this will be quite high? See, g is what the number of frames generated per frame time. We know that if in 2 frame time, number of frames totally generated per frame time, we know that in 2 frame time, if 1 frame is generated totally, whether it is new or retransmission, then I am going to get a collision free version. So throughput will be higher, right? So someone will say, okay, but you can send it in 3 frame time, 1 frame is generated, then also there will be no collision. But yes, but efficiency will be lesser. So throughput will be comparatively, we can say it will be lesser, because it will use your, it will create less efficiency because you are wasting the time there, right? So appropriately, when you will get so for which value of g you will get the best throughput, for how many frames per frame time if generated, then you will get the best throughput. Zero point 0.5, yes, it will be zero point 0.5, and that is what can be seen. This is a pure aloha. This is number of packets attempts per packet time. Attempts, that means number of frames that you are transmitting per frame time, packet time, whatever you call, right? So g, when g becomes zero point 0.5, at that time you are having the highest throughput. And what is that? Well, then it is decreasing again, the reason we have already discussed. So what is the value of the highest throughput at that time? Substitute value and give me the value answer. For that value of g, what is the highest throughput? So I will substitute the values. What is the significance of Priyanka having g 0.5? G is 0.5. What is the meaning of that? Substitute value of E and get the answer. Janil. Priyank, let me know what is the significance of having G value 0.5. What my question is to you, what is the significance of G is equal to 0.5? Meaning, I'm not asking G raised to minus 1 if K is equal to 0. Where you are stuck, Priyank, you can unmute yourself and ask me. What is the significance of G having 0.5? That is what my question is to you. If you will tell, then you will understand automatically. Tell me what is the meaning of G is equal to 0.5. What is the significance of having G 0.5 value? And I think no one is interested in answering what is the maximum throughput. See, I'm not interested if you are not able to answer me the questions. Okay, so 18.184 is in 2 frame time only if 1 frame is transmitted. True, that is what the meaning is, and that is what we wanted. In 2 frame time, there should be only 1 frame to transmit, right? Yes or no? That is what we desired. And if we are having g value higher than that, that is more frame per frame time as transmitted, will it be better? Higher value of g, like g is 1 or g is 2, will it be better? No. Can they be smaller? G be smaller? That means in 3 frame time or in 4 frame time you are transmitting 1 frame. Will it be better? You could, you are free here to transmit, right? You are free here to transmit, but you are not transmitting, so you are wasting the efficiency. It is not also better, na? It is not optimal. That is true. Getting Priyank? Okay. And yes, answer is 0.184. So what is the meaning of that? Throughput is 0.184. How many percentage is the throughput? Percentage wise. What is the mean? How many percentage? How many percentage it is? 18.4 percentage. So what is the meaning of that? 18.4 percentage of the frame reaches successfully without collision. So if I send 1,000 frames, 184 frames will reach successfully. That is the meaning. Only 18.4 traffic reaches successfully. So this is the, okay, whatever it is. But of course, as soon as you are ready, you are transmitting. You are not having any other policy. This very simplest most one scheme that we had here, right? So that is a problem here. What is the problem? That your throughput is very less. We will come to this example, but I'm not sure whether the time will remain or not. So we will take that if time permits. Okay. Now we are going to. So this is what the Aloha was. As soon as I am ready, I will transmit. I will not take care about that of this time slot. It is a continuous slot. So as soon as I am ready, I will transmit. Okay. So this was the distribution of the frame. Anytime anyone can start. But now next is the uh, slotted Aloha frames in slotted Aloha. So here what it is, that if I'm ready, I'm not going to transmit immediately. I will wait for the next slot. Okay. So suppose this is the slot time. Let us take this as a slot time. So slot time is say 1. This is 2. Then this is 3. And then this is 4. And this is 5. So at time 1, if I am ready, then I can transmit. If I become ready, so suppose this machine becomes ready at this moment, right? In pure law, what was happening? It was free to transmit. Okay, but in slotted law, what will happen? Suppose I am ready at this moment, I cannot transmit. I have to wait for the next slot. My next slot will begin at 2. So this will start transmitting at next slot. Okay. Now suppose at this moment station 1 is ready, and at this moment of time station 3 is ready. Can they transmit 1 and 3? Can they transmit at this moment? No. So they will wait for the next slot, right? In the next slot, both are permitted. I mean, we are not having anything here. We are not listening. We are not having any other policy. We are just waiting for a next slot. So what will happen here? Here it is successfully because in my slot only one frame was there. This is successfully because in my slot there was only one frame. Here what will happen? Collision will take place. Here collision will take place. Okay. Okay, fine. Now, if collision happens, then what station 1 and station 3 should do? If collision happens, retransmit. Should they wait or they should immediately retransmit? Should they wait or they should immediately retransmit? Random amount of time they will wait and then they will retransmit. Okay, true. So that is fine. And so what will happen? So now can you tell me what is vulnerable time here? What is vulnerable time? If in that duration no frame is there other than me, then my frame will be successful. If in that duration there is no frame other than me, then my frame will be successful. That is vulnerable time. Can you tell me what is vulnerable time for slotted Aloha? How it can be 0? What is one frame time? Yes, it will be one frame time. So in what will happen in my frame, if in this duration no one transmits, then my frame will reach successfully, right? In one frame time there should be only my frame. In my frame time there should be only my frame. Okay, so that is vulnerable time. So that will be so now let us do the same analysis here that we did. So here again we are assuming that Poisson's distribution n and g value will be same, just the scheme is different. As soon as you are ready you will not transmit, you will wait for the next slot. That's it. So probability of so now I want to find out throughput is s is equal to g into p success, right? So what will be p success? How, when I will be successful? If there will be no frame, in how much time? In how much time there should be not frame? Or how much time there should not be any frame? Then my frame will successfully? Yes, it will be one frame time. One frame time. So what is the value of k, and what should I change the value of g here? Should I replace it with 2g? Do I need to change this equation with 2g? No, right? And what should be the value of k then? Because I want to find out for one frame time, this already gives me equation of that probability of generating of k frames in one frame time. So I don't need to modify this equation, just I have to substitute k value 0. Yes, substitute g value 0. What will be the final answer? What is probability of success? Substitute k 0. Yes, it is e raised to minus g. So what will be your throughput? What is the throughput of slotted aloha? Yes, it will be g into e raised to minus g. So this is for aloha, and g into e raised to minus g will be for slotted aloha. And this indicates because of slot, my vulnerable time reduces, and that is what the impact of that. Okay. Now tell me one more point. When the throughput will be highest in this slotted aloha? When do you think that throughput should be highest? For which value of g the throughput should be highest? Yes, for g is equal to 1. It will be for g is equal to 1. Yes, it will be for g is equal to 1. What is g? G is in one frame time, number of frames generated in one frame time. In aloha, what happened? In aloha, that happened in two frame time, there should be only one frame generated. But in this situation, in one frame time, only one frame should be generated. So g value should be 1 for the maximum, to satisfy the vulnerable time condition, and hence to obtain the highest throughput. So g value 1 will give you highest throughput. And what is the value of that throughput? What is the value of that throughput? 0.37, or yes, you can say 36.8 percentage. So can you see the double throughput here? 36.8 percentage of throughput. So here we are, if I'm transmitting 1000 frames, then 36.8 frames will reach successfully. Okay, that is 368 frames will reach successfully. Okay, so this is what the throughput is. One more one more point is given here. Is what is the probability that I will be successful in kth attempt? What is the probability? Find the probability of success in kth attempt. You want to find out that you will be successful after kth attempt. What it will be? So when you are successful in kth attempt, can I say you are unsuccessful in k minus 1 attempt? Okay, so that you were unsuccessful for first attempt, then second attempt, then you reached to k minus 1 attempt, and kth attempt you were successful. So what you have to find out, if you want to find out the probability of being successful in kth attempt, that means you have to find out what is okay. So now, okay, we will go to this, but can you tell me what is the probability of success here, and what is the probability of being unsuccessful? When will you be successful? We just calculated it. What is the probability of success? What you calculated for aloha? What was the probability of success? Yes, it was e raised to minus g. So can you tell me what is the probability of being unsuccessful? What is the probability of being unsuccessful if this is the probability of being successful? Yes, it will be 1 minus. Yes, it will be 1 minus e raised to minus g is the probability of being unsuccessful. Suppose you are successful in third attempt. That means you were unsuccessful in the first attempt. Then you were unsuccessful in the second attempt, and third time you will be successful. So if you want to find out probability of being successful in the third attempt, that means you have to find out what is the probability that you will be unsuccessful in the first attempt, and you will be unsuccessful in the second attempt, and you will be successful in the third attempt. Yes or no? So can you tell me what will be the equation if I want to find out probability of being successful in kth attempt? Yes, it is going to be, uh, if you are successful in kth attempt, that means you were unsuccessful in k minus 1 attempt. So you will have probability of being unsuccessful k minus 1 times. Here you were successful 2 times. So actually you can write 1 minus e raised to minus g square, or you can write it a k minus 1 even, suppose you are finding for k, and into e raised to minus g. So you were successful in kth attempt. Okay, so this is what that probability is. I have not mentioned that in this PPT, but of course it is available in your textbook and we have covered that too. It is just not mentioned in this. So please read the textbook for this probability equation. But I hope you are clear with this. Anyone having doubt up to this point? Anyone in case have doubt, please ask. Otherwise, I will go to the next point. Any doubt in this equation? And one more equation we should learn. Of course, proof is possible. We are not going to take it. That average number of attempts needed to transmit is e raised to g. So average, how many attempts will be required? Like here, you were successful in kth attempt, right? So on an average, how many attempts you need a station needs to do before being successful? That is expected number of retransmissions, we can say, expected number of transmissions, average number of transmission it has to do for being successful is given by this equation. So this is what we are not going to proof is not difficult, but time is a limitation, so we are not going to go with this. Okay, in textbook it is given, you can explore and you can understand it. In case in doubt, you can contact me anytime, that's okay. Okay, so this is all about slotted aloha and aloha. Now we are going to take the examples. Any doubt in the concept? Then we can start with the examples. Examples, you are going to do it quickly and you are going to let me know about quick answers, right? So question is a pure, this is, we are doing this example since years, but this was similar just by changing these values. The question was asked in GATE 2021, right? This PPT, of course, we are following this question. This is given in textbook itself, right? So this question is from the book itself, but this was just by changing some values. It was asking GATE 2021. So what is the point here, that you can understand the importance of this type of questions, right? Many other are there. You can just go through the aloha and sorted aloha questions and this multiple medium access control protocol questions. Not many questions are there, and they are very important one for the GATE perspective. Okay, so now tell me here how you, what is the question to you, what is given to you? A pure aloha network transmit 200 bit frames on a shared channel of 200 kbps. What is the throughput if system produces? What is the question to you to find out? What do you have to find out? Which entity will you find out? And what is the equation for that? S. You have to find out S. And what is the equation for the C? What is the equation of S for pure aloha? Yes, it is G into e raised to minus 2g. So what is unknown entity here? This is what I need to find out, right? What I don't know in this, G. So what is G? What was the definition of G? G I need to find out. What is the definition of G? Number of frames per what? Per second? Number of frames per frame time. Number of frames per frame time. So what is given to me? Number of frames per second. Do I need this? I need to find out what is the number of frames per frame time. So what I need to know? Frame time. Can I find out frame time? What is frame time? The amount that the value of time or amount of time that I need to transmit a frame. Can I find out frame time? from the other given information. How to find out frame time? What is the size of frame? Mu and c, don't go with that. You just use logic. That is for the static methods, right? Right now we are going for FDM and specifically TDM. Those terms were for that. Use your logic only. Don't go with the equations and all, right? This type of questions majorly can be solved by logic only, right? Yes. So what is already given to us? Yes, the answer is correct here. Uh, Frame size is given 200 bit. So what is given to me in 1 second, I can transmit 200 kilobits. In 1 second I can transmit 200 kilobits. So in how much time I can transmit 200 bits? So it is going to give me the time taken to transmit 200 bits. That is one frame time. Yes or no? So what it will be? 1,000 seconds. Without units, won't it be scary? Amount of time taken to transmit a frame, that is 200 bit. I need to find out what is that. Are you following this? Are you with me? It will be 1 millisecond. True. Yes, it will be 0.001 second. That is 1 millisecond. Yes, it will be 1 millisecond. True. It will be 1 millisecond. Correct. So now so one frame time is 1 millisecond. So what I need to find out? Number of frames in 1 millisecond. What I have, number of frames in second. Can I find out G for first case? So tell me G for first, second, and third case quickly. G for first, G for second, G for third. What I know is now how many frames per second. What I need to know, how many frames per millisecond. So what is G for each? Yes, it will be 1.5 and 0.25. 1,000 frames in 1 second. That is in 1 second, 1,000 frames, right? So we can say actually in 1,000 millisecond, 1 second is 1,000 millisecond, 1,000 frame. So in 1 second, how many frames? So it is going to give me one. That is what G will be, one for that. Same way, in 1,000 millisecond, 500 frames. So in 1 millisecond, how many? So it is going to give me 0.5. I hope everyone is clear with this. If not, ask me. I can stop. Everyone is clear with this G values? Okay. Now tell me throughput. First throughput. First throughput only. Other two you can try. I'm not going to waste time. Here what I want to explain, I will explain with the first. First throughput only. First throughput. G is 1. E raised to minus 2G. G into e raised to minus 2G. 0.135. So can you tell me how many frames will reach successfully? 13.5. How many is it? The question is, how many frames will it successfully? 13.5%. I'm asking how many frames will it successfully? Not 13.5 percentage. 13.5 percentage of what? 1000. Yes, so it is going to be how many frames will it successfully? 135. Yes, it will be 135. So quickly tell me for second, how many frames will it successfully for second? Not for third, for second. How many frames will it successfully for second? So tell me throughput and then number of frames. Yes, it will it be 0? 0.184. Okay. 0.184. Yes, it is going to be 0.184. So how many frames will it successfully? No, that is what you should not do. That is what you should not do. 18.4 percentage of what? Yes, it is going to be 92. Yes, are you clear with why 92? Huh. Uh, Not that way. 184, 18.4 percentage of transmitted frame will reach successfully, right? How many frames you have transmitted? 500, right? That's why. Is it clear? Fine. So everyone is comfortable now. For the third one, you can try. Whatever the number you will get into 250 is going to that many frames will be successful. Um, this question is a question I have written for the uh, pure aloha solution. I will edit. Okay, tell me for this what it will be for slotted aloha. What it will be? Suppose it is slotted. Change it to slotted. We are not going to do the entire example. For slotted, tell me what will be. Will there be any change in the answer? So what will be g value? Will g be same or different? Will g be same or different? Okay, what is g? Yes, it is number of frames per frame time. So g is going to be same for each. What will be the difference here in the equation of throughput only, right? So here instead of minus 2g, you should use e raised to minus g, right? Otherwise g will be same. It is logic wise it will remain same. Just equation here will get changed, and hence just for one first, let us calculate for first. What it will be for the first one? When g is 1, what will be throughput for g is equal to 1 for slotted aloha? What will be the throughput? It is well known, no? G is equal to 1. What is the throughput? Maximum throughput? What is that? No. For G is equal, this is for aloha, na? We want to go for slotted aloha. So this will not be there. Yes, it will be 0.37, or we can say 368, 36.8. So 368 frames will reach successfully because of this 1000. Right, so that is what is given. 368 frames will reach because of 1000. But next time you should, whatever you get, your s value should get multiplied with 500, because total number of frames transmitted at 500. So this question, of course I'm going to edit both the case. You can calculate this for both sorted and pure. It is okay, right? Now go for next question. This is the next question. All right, this is the next question. Solution is not required, just go through the question. What they are asking? Which entity they are asking to you? So how many stations are there? How many terminals are competing with each other? What is n? How many number of stations are there who are competing for a channel? 1,000 stations are there. Okay, and each station is generating how many requests on an average per hour? 36. So per hour, totally how many requests are generated? One station only 36 requests. Yes, it will be 36,000 requests per hour are generated. Okay. What is that request? What is the significance of request? Frame is generated, right? They want to transmit. They are having frame to transmit. Okay. So fine. And what is the duration of a slot? It is 100 microsecond. And what is the question to you? What is channel load? Which entity? Is it vulnerable time? Is it S or is it G? Approximate total load. Total channel load. Yes, it is G. Channel load is what? That number of frames in the channel, right? That is channel load. How many frames are there in the channel? That is channel load. So it is question is G. So G is the question. Is it so? What is how G is defined? How G is defined? Number of frames or number of requests here. We can say number of requests per frame time. Hmm. Yes, it is number of frames in per frame time. What is the frame time here? In slotted Aloha, can slot size be smaller than frame time? It is generally equal to the frame time. For simplicity, that is what we are assuming, right? So what is our frame time? Is the slot time, right? And what is that? 100 microsecond. So frame time is 100 microseconds. So what we need to find out how many requests per 100 microsecond. And what we already have is, are you clear with that 100 microsecond will be my frame time? And what I have, 36,000 36,000 requests per hour I have. So just I need to have some conversions only. This already I have. I need to convert it for this only. Do it quickly. Let me know the answer. G. 36,000 requests per hour. No. G is 100. Is that your point? No. 100 frames per 100 microsecond. Then no one, I mean, throughput will be, I mean, uh, on the ground. You will, I mean, how you can send in so many frames per frame time? Think, no, calculate. See, this is very simple. What you need to do? Okay, tell me how many frames, how many requests per second, Prince? How many requests per second? 10 requests per second. Yes, 10 requests per second. So in 1 second, 10 requests So in 100 microsecond, how many requests? So this is second, na? So we can write 10 raised to 6 microsecond because I have to write the both unit same, na? So in 10 raised to 6 microsecond, 10 requests are there. Then in 100 microsecond, how many requests will be there? I need to know in 100 microsecond how many. It will be 0.001. Hmm. So G is 0.001. Understood, everyone? This is just, see, logic wise nothing new, just it is some conversion process, right? Nothing else. This is new one. Do this. Okay, now first, in first question, what is, which entity, which variable is to find? G. First is G. Second is S. Third, how will you say the channel is overloaded or underloaded? Use your logic. See, here we don't go and try to think, okay, we have which equations we have studied. No. If it is a slotted aloha, when will you think that what is slotted aloha? In one slot, at every beginning of slot, I can transmit. And if collision occurs, I will wait for the random amount of time and I will retransmit. Okay. When I will think my channel is uh, properly loaded, overloaded, underloaded. When will you think that my channel is overloaded in slotted aloha? I told you, don't go with your equations. You will not reach to the correct conclusion, Jenny. Go with your logic. What I ask, significance wise, tell me in which situation you will say that my channel is overloaded or underloaded. More than one frame in one slot. Absolutely correct. So what is it? Is underloaded or overloaded, or it is equally loaded, or critically loaded, or properly loaded, whatever you call. Overload. Yes. So when it is overload in one slot, if more than one frames are there, then it is overloaded. Which value of G will indicate that there are more than one frame in one slot? Which values of G will indicate, not which range of G will indicate that there are more than one frame in one slot? What is G? G is greater than 1. True. If G is greater than 1, so whatever you find, if G is greater than 1, what you will understand? That means it is overloaded. And if G is less than 1, then it is underloaded, right? And if G is what we can say, it is G is equal to 1, it is properly loaded. For if it is pure aloha, then suppose it would have been pure aloha, then what would have been the value here? Will it be just G greater than 1, G less than 1, G equal to 1? G will be, yes, G will be greater than 0.5. So here vulnerable time comes into picture, right? So in my vulnerable time, if only one frame is there, then my channel is properly loaded. Otherwise, it is overly loaded. If it is more than one frame, and if it is less than one frame in that my vulnerable time, then it is underloaded. Understood? So fine. So now we this is not big deal for us. Whatever we will find from that, we will immediately conclude for the slotted aloha. Once I find G, this will also not be big deal. I know the equation. What is that equation? G into e raised to minus G. This is slotted aloha. Now only question remains is to find out G. How will you find? What is given to you? Now you have to see what is the information given to you. What is the meaning of slots are idle? What is the meaning of slot becoming idle? No, 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 no. No, no. Answer is not correct here. What is 0.9? That 0.9% of slots are no, no. What is no? See, what is my slot are idle? Idle is it is not ideal. It is idle. What is the meaning of this idle? No frames are transmitted in that slot, so it is empty slot, right? It is empty slot. That means what is the value of k here? So what is the meaning of that? Suppose I am randomly picking up this k value is 0 here, right? K value is 0 here. So 10% of slots are having ideal. That idle, that means in that k value is 0. Now, um, and okay, and what is given 10% of slot are idle? That is, if I'm randomly picking up a slot and it is being idle, what is the probability of that? Suppose I am randomly picking up a slot and it is idle, what is the probability of that? 0.1, right? So probability of slot becoming idle is 0.1. That means probability of k becomes 0 is 0.1. Can I say like that? Yes or no? That is, my k value is 0 and probability that 0 frames is generated is 0.1. Yes or no? That probability that 0 frames are generated is 0.1. Now what probability and all those things I have studied somewhere, where it is? It is somewhere here, right? K value is 0 and this value, probability of k, probability that no one will, only 0 frame is generated is 0.1. Probability that k value is 0 is 0.1. Can I say so? K is 0 and it will take 0 and the probability is 0.1, right? Are you comfortable with this two mapping? Are you getting the idea here? Should I explain this or are you clear with this? Okay, so k value is 0 here, so so 0.1 is equal to what? 0.1 is equal to e raised to minus g, right? So what is g then? Yes, it is 2.30. Yes, g is 2.30. G is 2.30. So according to that, what will be your throughput? This will be 2.30. Because e raised to minus g is equal to 0.1, then you will simplify this by taking ln or whatever, right? You can take ln 0.1 and use minus sign. So g will be 2.3. So what will be s then? Is it 0.23? Yes, it is 0.23. And is it overloaded or underloaded? Yes, it is overloaded. So yes, it is overloaded. Okay, so this is all about, and you can see that throughput is less than the maximum throughput possible. It is overloaded. So this is all about different examples of aloha and slotted aloha. Are you clear with all the concepts? See, many other possibilities are there, right? We have tried to cover the different types, but again, many others are there. If time will permit in future, we will consider more, but I don't think the time will permit. So you start doing on your side, and wherever you stuck, you can ask me anytime. Okay. So I'm concluding Aloha sorted Aloha part here. Right? Any doubt in case, please right now ask, or even you can ask me later. But start practicing examples of unsolved Tenenbaum, and of course many other gate previous year gate questions you can also solve. So generally, in every 2 3 years, one question from make protocols comes, right? So you should not ignore this. Fine. So this is all about um, theory part. Now we have to go for our today's lab. Okay. Today's lab is routing protocol, right? So we will start with routing protocol, routing algorithm, rather I should say, not protocol. We have not taken protocols, so we should say this algorithm. So we are starting with shortest path algorithm, Dijkstra, right? So how are you going to implement? Give me the idea that how you will use shortest path algorithm to create the routing table. Mark my words. We want to create routing table. What are the entities in the routing table? What are the different fields of the routing table? What are the different fields of the routing table? Interface, yes. Then next hop, right. Next hop, mask, right. And network address, yes. IP address. These are the major ones, right? So, fine. So now what I need here is I want to feel these things. I want to feel what we can say this these entries of my routing table. So here, if you will see, the interesting part is next hope, right? Next hope is interesting. So, and sometimes this was hope's specific one, and if you sometimes in some routing tables, some we are keeping the entire path as well, right? So, in now tell me how are you going to? So next hope part is important, right? So whenever I apply my routing algorithm, I should be able to fill some of the fields from this routing algorithm, right? So now tell me, think over this. Next hope field is important in this case. Think over this. Think over Dijkstra. Make a strategy. What are the inputs you will need? What are the outputs you are going to generate? And which of the other terms, in case you can feel from this routing table from that. So think over that and let me know in 2 3 minutes. I think 3 minutes are sufficient for thinking of that, right? So just go through. Dijkstra is the routing algorithm. What are the inputs you will need? Okay, and what are the outputs you should generate so that some of the fields can be filled out. So this is what my question is. 3 minutes to think. I will come back. I will ask you again. If you are ready before that, of course you can report. Okay, so what will be your input? What will be your input? Graph. Yes. And how will you get that graph? Graph should be your input, right? So for that, okay, graph. How are you going to take that input here? Implementation wise, let us discuss implementation wise. Then network wise, I'm going to take, yes. You will ask nodes and edges, and you will take it in 2D array. Yes. So implementation wise, it will be. Yes, it will be from. It will give you the metric, right? So you are going to use a matrix 2D array, and from each node to each node distance, you are going to write there, and you are going to get the inputs. Good, understood. But the case is, network wise, how will you get that graph? Here in Dijkstra, what we are assuming that we are aware about this graph, right? But if you don't have that graph, then if you remember in link state, we are broadcasting the link state packet, so we are aware about this entire graph situation, right? We know that actually we are getting that matrix itself, that how each node is, who is the immediate neighbor of each node, and what are the values, what is the age value of that, right? So network wise, if you are not aware of this graph, then you have to use link state packets. You need to exchange them, you have to broadcast them, and you can get that metric, or we can say you can get that graph. So are you clear with network wise and implementation wise what will be the input side? Clear, everyone? Okay. Now Abhi's point is very good. What is a root node? So as a router, if I know the graph, should I be aware about for which path I should find out, for which node I should find out the shortest path? So as a router, I should be aware that how to reach to connected to receiver, right? But as a router doesn't know that um, which node will be the receiver, right? Because there will not be only one receiver, right? So destination is correct. Your answer, destination, is correct. But for when it is a network and we are communicating, can we define that particular machine will be destination all the time? So for which node we should be able to find out the shortest path? No, see, I think I need to show you some point here. Okay, so suppose this is the network, right? If I was aware about this graph, that's good. Otherwise, I will share the link state packet and I will create this type of graph. And as an input, what I'm going to take, as an input, I'm going to take like uh, how A is connected with all other nodes like B, so with A, with B, with C, with D, and E and F. This type of metric, and then same thing we will repeat for B, C, D, and E and F. This type of metric we will have, right? And this will give me that idea about this graph. So I think everyone is clear up to this point. Now question is, okay, finally then I will um, I will find out the solution, right? And I need to assume that which node I am. Suppose in this graph I am the particular one, right? Suppose I am this node. Suppose I am the B node, right? So what should be the entries in my routing table? For which nodes I should have the entries here? For which network address I should have the entries? For which IP address I should have the entries? That means for which nodes in the network I should know the shortest path. From B, is it sufficient to find out for F? From B to which nodes I am going to find? From B to A, only CF is sufficient. All other nodes it should be, right? It should be all other nodes. So I should be, so in my network ID field, one of the field, that IP address. So what should be the what should be my output? I should know the shortest path to whom. Short from I have to ask that, I have to first understand that who am I, who is the source, right? So you will decide that source first, right? And suppose you are deciding that B is the source first, then your output should be for address to A, then address to C, address to D, address to E, and address to F. Why? Because you don't know that as a router you will need whom at which time. So IP address field is clear to you. Which address will come? All other nodes are going to come. Are you clear with it? Okay. Mask part, right now we are not making it complicated, but let us make it simple. Routing part is more important than the forwarding part. So right now focusing on the routing part. So let us go with the next hope. Now can you tell me, suppose I am finding path to D from B. What is actually correct answer? Path to D from B. What is the correct answer? Yes, the path is B, C, D. Suppose it is the answer. Suppose we have one more node somewhere. A. Why A is not the source? No? B is the source. A B, we have assumed that B is the source, so it will be BCD. Right. Suppose we have one more node here. Assume that we are having one more node here. For simplicity, I am explaining. No, for other case, suppose I am having X node here. And to reach to that X node, we have path like this. Suppose I, if for the entry of X, this is the path. What should be my next hope for this entry X? Suppose the path to reach X is B, C, D, and X. What should be my next hope? Yes, it should be C. It should not be D. So generally what you do when you find out shortest path to X, do you find what? Parent node. That is what the general practice is. That is how you generally practice. But what we need here is this node. Suppose it is X, then Y, then P, whatever it is. But I need this one. Understood? So that next hop part you are going to take care about. And additionally, what I need is that entire path you are going to write here. Entire path you will mention here. I want to preserve all the nodes in the path. Suppose I need this path. So whatever the shortest path is in my requirement, entire path should be preserved. Is it clear? Up to this, everyone is clear what is requirement? Are you clear with the requirements? Great. Now next requirement is, should your algorithm be specific for B only? Whatever you implement, the same code, if I run for C, should it run or not? Whatever code, the router will be just different machine, it should run, right? So this, that implementation will be made by asking source to the user itself. So whenever you will run it for C, you are going to change the source to C, and then it should work. So your implementation should ask source first. Who is the source? It should ask the graph. Of course, it is required, right? And uh, third, it should ask. It should not ask, but it should generate the output for. It should. This is the input. Source is the input, and this is the input. Then output one will be what? Output one is. Um, that all for all the routers, for all of the routers in the path, for all other machines in the path, I should be able to find out the next hop and in the interface, right? And the interface. But right now, let us keep it next hop. Interface will, for the immediate one there will be interface. Otherwise, there will be next hop itself. But let us not complicate it. For all of the router, it should be able to find out the next hop. Plus, it should be able to find out the path, and of course, what? Cost. What is that shortest cost? Cost is also one of the parameter of a routing table. So output should be this type of table in which all the routers, next hop value, path to that router, and cost to that router should be the output. Is it clear, everyone? And what should be the input? Input should be the graph with more than 8 nodes. Whatever graph you want to take, but input must be including more than 8 nodes, or at least 8 nodes, right? Start, start implementing. You tell me what it should be. Cost to next hop or cost to destination? In routing table, what we include? No, routing table includes what? See, routing table says that if you want to reach to X, if you want to reach to X, this will be the cost, and next hop will be this. Why this cost will indicate from X to next hop? See, what your logic says, if I want to reach to X, who will be my next hop? What will be my cost? What will be my path? Getting the idea? Are you getting, Priyank? So what will be the cost? Cost to? See, A, B are the immediate one, na? So it will be the next hop itself, there itself. Whether it is for the next hop or whether it is for destination, they are same only because it is the one. They are the, if you want to reach A only, then there is no next hop, it is itself a destination. But if you want to reach final cost, cost to, see, what is the significance of A here? What is the significance of X here? What it mean? What is the entry for C mean? What is C here? Yes, it is destination. It is, yes, to reach there. Yes, if you want to reach here, this is the destination, right? If I want to, if I'm a B, if I want to reach here, then this is my destination. IP address of the destination itself, destination network itself, we are keeping here, na? So X is the destination, A is the destination. So what I want to know is that suppose I want to reach to say F. If I want to reach to F, then I will use this entry. What it means, suppose you want to reach to F, suppose you are following this path, not the direct one. Suppose you are following this path, then next stop will be A and the cost will be this, right? So total cost, final cost to F only will be written here. You are not going to write cost to B to A, B to E and B to F then. You are just going to write the final cost to F. Is it clear? Okay. So start working and let me know if it is done. Input will be the graph and source. Yes, it will be, input will be graph and source. True.
Hello, ma'am.
Huh?
I am talking about that in the table we have next top column, and then third column for the cost is required or not.
Next stop is what? Next stop.
Immediate node from that IP.
And cost is what? From, suppose from B, if I am considering say F, I'm assume that this is the path, right? From B to F, suppose this is the path I'm following. Assume that. Okay.
Yes, ma'am.
So what will be my next stop for this path?
A.
And what will be the cost for this path?
For the whole path or cost for
Whole
the immediate
immediate,
node.
it is not required. See, cost to reach F, the cost to reach A will be mentioned here. From B to cost to reach A will be mentioned here. The shortest cost possible from B to A will be mentioned here. From B to E will be mentioned here. The shortest path and cost to that path to reach E will be mentioned here. The
Yes, ma'am.
shortest,
Got it. Got it.
understood?
Yes, ma'am.
Uh-huh. So are you working on that? Have you started? All of you? Report me as soon as it is completed. That is C is preferable. You can go with C++, but do not use very I mean, just assume that you have very low functionalities available. Okay, C++ is fine. Okay, fine, but assume that you don't use very much available functionalities. Start implementation so as if you are not having any facility, so that logic wise you will be more clear. That's why. Okay. You can use whatever structure suits for the graph, right? You can use it, and if it is a better implementation, it's okay. But what I suggest is, see, what my restriction is that you should not use inbuilt libraries which are directly computing something for you. Okay, so otherwise, representation wise, you can use anything. That's okay.